have a lot of questions from the first video, so I thought I would answer that about how the pilot and how this whole system works. Sometimes you're seeing this pilot wobble like this. It's supposed to. All right, so what this is doing is lock is rigid. The entire thing floats. So we lock the spindle. We indicate the head in as close as possible. We lock the spindle. We make the head float. We put this into the hole. Okay. Now imagine this hole might be just slightly off. I mean, we're talking a thousandth of, which would be like a 100th of 1 degree. I mean, something infinitesimal. You unlock the pilot, and that allows it to go in perfectly in line with the guide, okay? Then, when it is perfectly in line with the guide, going up and down perfectly straight, then we come up here and we lock everything in place. Now, this spindle, the pilot, still stays floating because everything has become rigid. The pilot is allowed to float in there because as soon as you lock the pilot, watch it right here. When you lock the pilot, you see how that moves and jumps? So the pilot can only be locked in one perfect perpendicular position to the quill. Sometimes that we might be just the machine allows for a little bit of variance, so it does a perfect valve job concentric with the valve guide, even if your machine is not perfectly put in place. So it allows it a little bit of deviation. So when you see it, you're seeing this valve guide move like this. That is intentional. That is what makes this better. All right, now let's get back to seeing how you valve job this stuff, how we cut multi-angles, how we do it all in one cut, and how you properly set seat heights. All right, so what you got here is it just intersects that. Now a lot of times they'll intersect even harder and they put bigger exhaust seat on it. We don't really need a bigger exhaust seat. And you can see machines in there. I think I'm got a little bit of a ledge right here. Actually, I think I just hit it with a deburr tool, to tell you the truth. It's really nice right through here. Nice flat. It just has a little burr ledge right there. I think I'll take off. Looks good. So I'm gonna cut the rest of these seats to that bore. Then I'm gonna narrow these up, put them in the freezer, put them on the ground, drive them in. I'll meet you back here after that. Okay, got the seats in. All the seats are in the head. Now, the ID of the seat is smaller than my throat by about 150 thousandths total. So I have to come in here before I cut the valve job on the intakes and exhaust. So since we have the exhaust all set up, I come in here with the same style of counterbore tool and throat that. So it's gonna just make that seat the same size. I'm sorry, it's gonna make that seat the same size as you can see here, as the throat. All right, as the port itself. So we'll cut that thing and I just sneak up on that, and then once it's the size, then I'll just go over and do the next ones. I could set it up on the fixture, which, I don't know, maybe I will. Find out exactly what size. I can't remember what size the exact size of the actual port is. And sometimes it's not perfectly round down there either. in the port. So sometimes the shape of the port isn't exactly round. And stop this and get the chip off of there. Now these are not a beryllium seat. These are a special alloy on the exhaust. It's an exhaust alloy and then an intake alloy. I'm not a metallurgist. This is what we use and it works. So I could pretend like I know absolutely everything, but people that know everything are just pretending. Because you can't. Alright. Alright. Let's get to the... A little bit of lube for the tool. Alright, I still need to go bigger. Show you how I'm adjusting this tool. Get rid of the chip. Oh yeah, that's nice. Okay, so we've throated that. Yeah, it still has probably, oh yeah, solid 10 more to go. Probably actually more like, yeah, probably 10 more. I'm gonna leave it right there, and then I can do a little bit of hand blending on it after I do the valve job. So I'm going to do the same thing to these other 4 ports right here, and then I'll cut the valve job on that seat, and I'll show you that. Okay, you can see right here. Oops, sorry. I have valve jobbed that seat and then lapped it in to verify that the seat is concentric all the way around. Everything looks good. Pretty happy with that. It's perfectly placed on the valve. So now I have my tool. Everything is all set. Where's it at? There we go. So my tool is set. Now what this tool does is, you can see it right there. It's actually cutting all the angles all at once. When I lap it, it's only showing the valve seat angle. Now, this is a little bit wider because I can make this narrower, and yep, it probably flow one seat. Here, I'll show you, sorry. You can see here that the valve seat it's a little wide, but that's because this is the exhaust valve seat. We want to have this wider because it transfers heat better, and in this drag and drive application, it's going to end up getting wide anyway. So there's no sense machining that seat to be a very narrow, to like pick up 1 CFM or something stupid. So that's exactly what we've done. Is I have, see, I'm feeling my valve job here, made a nice, really good seat that is going to seal very well and transfer heat on these drag and drive applications. So what I'll do here now is I'll show you how I got there, show you what that does and how it's cutting. You know, here we've just throated it. Now we're going to valve job that, and then I'll just valve job all of them, come in and lay out die, and then lap them just like this first one over there. Now the old Rottler SG9 here is really just a outstanding machine. And you might be asking, how long did all this take? I am going to be into this thing for about 6 hours. There's also the reason why. Now this is putting seats in, boring them, throating them, doing everything on one head. But I'm also kind of proofing this thing out. I could be a little bit faster, but all things said and done, it would take 1 solid day to do two heads, put seats in it, and valve job it. Solid 1 day to do it right and do everything, and that's why the stuff is expensive. It takes time for sure. Alright, about here it starts hitting the top angle. Here pretty quick. It'll actually start ticking the intake seat. Right there, you can hear it go. Alright. Let that spark out. Alright. There's a whole bunch of seat material right there. Alright, let me zoom out a little bit. Let's move this over. Blends into the chamber really nice. I mean, I'm not even gonna touch it right there, and I just got a little thing I'm gonna touch right there, I think, but I really don't even have to. All right. Now remember, I'm going to come in and blend the bottom side of that. Everybody wants to know what this layout dye is. Here you go. Beach Chem. Beach Chem layout dye fluid. Let's air it out. Now I can see the seed in it, but I always like to lap it anyway. I mean, seeing the seed doesn't mean squat. What we want to do is make sure that it's concentric with the valve guide. The only way you're going to do that is lap it. Now I can also vacuum check the port. The Rottler here does come with a vacuum port option, which is right there, which is nice. And I think I can do that. Yeah, I can. We'll actually do that just for kicks and giggles here in just a second. You just have to make sure there's no opening into the port, obviously, which there's not. And let's see here. So I'll come in here, I'll lap this thing up. Alright. Now I know it's on the same, it's the same size, so I'm not going to check that again. All I'm checking for is concentricity. Concentricity, there we go. i.e. it's hitting all the way around, which it is. Looks very good, very nice. This special lapping compound here is like, I don't even think it has any grit in it. It feels like grease, but very, very smooth. Now, and this is just a used valve. We got lots of them around. Used valve from the SMX stuff. And let's put this in there. Alright. And then I will show you the vacuum port, vacuum deal. Alright. It's got a little vacuum line. You turn on the pump over here. Put it over the exhaust port. That right there is called sealed up. It is pulling, I don't know, 18 inches of vacuum. And if they're leaking, they won't pull any vacuum. That's just as much vacuum as this thing pulls. So that looks good, real nice. And I can check all of them like that. So I'm going to cut the rest of these exhausts, and then we'll go over. We're going to do the exact same thing on the intakes. So we'll do the exact same thing on the intakes where I throat it, then come in, valve job it. I'll show you that I'll do a little bit of blending here, and we'll do that to blend it into the port, and then I'll show you the finalized valve job. Alrighty, so the last thing I'm going to show you here is, so now I have cut the intake seats, and now I'm checking my seat depths to make sure, since this is brand new, to make sure that I am getting the correct depth on the seat. So what you see here are two valves that I've made up, and these valves go for these heads. Alright, and what this is a checking valve. Let's see, there we go. It's a checking valve. And so we drill into the center of the valve on a lathe, and you put a ball bearing in there, so it makes it easy to check with the bridge. So I know what my specifications are. And I actually am going to have, the intake seat is correct, and I actually have to cut the exhaust seat another 10 to make it the same. So here's the bridge. And so you got, oops, indicator, and then what you do is, let me get it on the light for you. So the little ball helps you find the exact peak much easier by having that little ball in there, and that gives me my heights. So I can compare that with all the rest of the seats or any other heads in particular. So I try to keep everything and maintain everything the same seat depth, so I have the same piston to valve clearance, same valve train geometry. So we try to make everything exactly the same, and that's how you do it with a checking valve. I know what the number is from the deck surface to that ball, and so we raise or lower the seat depending on what that dimension is. And same for the intake, right there. All right, so you can see I have these things lapped in. I just have to come in, recut that after checking it with my checking valve. And I could have done this right away, but I just wanted to go ahead and get everything roughed in first, because I knew that I can pretty easily come back and just touch it if I need to, which 10,000ths I will. And then the intake is right, so I'm not going to mess around with that at all. So I think everything looks really good here. I'll go ahead and I'll lap these other intakes in, cut the exhaust, 10 extra thousandths, and these things will be ready to go together. So that is how we put seats in and do the valve job on the SMX head, and any head in pretty much. Now another little thing I'll show you is, get this moved. There we go. Now, if you don't know about my valve system too, valve guide. Let's see, so I can do there. Okay, I'm all cut. Yep, I can loosen this. Show you. Now, exhaust valve guides. This is something I've been working on for quite a while. And they're a little dirty right now, so don't freak out about that. But that guide is actually right there. So this whole steel portion of the guide is actually the spring seat also. And then just has the guide up above. So it has a full bronze guide inside a steel guide. Take a look at there. Let's see. There you can see, and now it does make it larger diameter. This is quite a bit larger diameter. But I do not care. I will lose the 510 CFM flow or whatever. Don't really give a crud. For the sake of, and there's that intake or the exhaust port. For the sake of durability and making everything last. So that whole steel guide there really dissipates the heat, and then you have the solid bronze guide instead of a steel liner, or I'm sorry, instead of a liner like the intake valve. Now the intake valve doesn't care. So that is a steel guide with a liner, which is real common, but we do these and build this for a big steel guide to take care of all the heat issues and on the drive. Drag race only, doesn't really care, but long duration, need to help, especially in turbo applications. You have to help out that exhaust guide, and that has been just, so far, has been spot on the money with my car, Clark's car, Tom's car, everybody that's been out running. That has been spot on the money. So very happy with the old SMX head. And I think that's all I got for you today. So we covered seats, showed you my exhaust guide, give you a little bit of a look at the cylinder head just in general. But she's a pretty bad dude. Full of all sorts of coolness. I'm Steve Morris. Have a great day.